Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed Live. I'm super excited to have you all joining me today from wherever you're streaming from, whether it's Learn TV, Twitch, Twitter, YouTube, Microsoft Reactor, or somewhere else. We're excited to have you here joining us today, and we're going to be talking about some new content that we recently launched. And for that, I'm bringing on my colleague from the team, Silvano. Hey, Silvano, how's it going?
Hi, Anna, and good morning or good afternoon, good evening, everybody from wherever you are. Glad to be here and looking forward to this great show.
Awesome. Yeah, we're glad to have you here. And without further ado, today we're going to be talking about deploying IoT solutions with Azure SQL Database. Now, the exciting news about all of this is that we recently released a new module on Microsoft Learn, and that's at that short URL you see, aka.ms/Azure SQL IoT. But we went through the process of getting this content out on Microsoft Learn so you can really get hands-on for free. But before we get into a little bit more details about the content, I wanted to, talk to you, Silvano, and ask you a little bit more because I think when we started working on this a few months ago, you had some customers, you had some reasons why you wanted to kind of scale this motion. So can you maybe kick us off by telling us a little bit more about why we wanted to build this solution?
Yeah, absolutely. Basically, over the last couple of years, I should say, we've been working with a lot of customers around the world in their projects around assembling and creating IoT solutions based on the Azure platform, and specifically leveraging Azure SQL as one of the components of these complex solutions. And we've been learning a lot, and we have been over the course of the years documenting our learning, creating a bunch of articles that you will be able to access on our blogs and so on. And we also created a bunch of reusable assets like templates, Azure Functions and other components of these solutions that at the end we thought it was a good idea to clean up, to package together, and basically give back to customers and provide them with the ability to easily deploy in their own environments, learn, and potentially reuse those components as part of their working projects, right? So that was the kind of idea behind this exercise.
Yeah, definitely. And yeah, so we were able to basically take a bunch of content that Silvano and the team's been working on over the past few years and put it in a Microsoft Learn module. So that's what you're looking at now. Here is the module that we just launched, by the way. And you can see that it has different pages, it has exercises, and it's going to walk you through setting up this package solution that the team has built for the first time in a free way. So we'll take a look at the free Azure Sandbox throughout, but just wanted to give you a sneak preview. And then as we go through the session, we'll talk about different ways you can customize, and more generally, we'll talk about why Azure SQL, why and how Azure SQL Database is going to be good for IoT situations. Now, if you want to go through the module, just some things to be aware of that we kind of assume that you have some introductory knowledge of Azure IoT. You can navigate the Azure portal. You're familiar with some of Azure services, including things like Azure SQL Database or just databases and querying in general. But all that being said, we do try to make this accessible for everyone. So even if you're not necessarily checking one of these prereqs, I think you'll still get something out of the module. And at the end of the day, right, like Silvano was mentioning, our goal was to be able to help you kickstart your IoT solutions, maybe using the template provided, not just for the scenario that we'll walk through kind of as the fake scenario for the example, but also for other scenarios. And Silvano is going to help us understand how we can customize the template and how it can scale even bigger than you'll see it scale in the learning module. So with that being said, let's get right into it and talk about the scenario for the Learn module. So this is just one example of a scenario. Again, this is a lot of words here, and you're probably familiar with lots of different IoT scenarios, but this specific scenario is is assuming you work for a distributor and your role is managing the logistics of shipping goods between main warehouses. So you're probably familiar with the scenario where you're kind of doing fleet management of potentially thousands and thousands of trucks. And ultimately what you're trying to do is do some sort of predictive maintenance. So you want to be monitoring the health of these devices, of these trucks, essentially, to try to kind of preemptively, understand when some sort of failures might occur, so you can do maintenance as opposed to breaking down on the side of the highway in between the warehouses. So you're looking for something that can ingest thousands of entries per second, have unlimited storage, and really help you monitor the health of your fleet. So that's kind of just one scenario. Of course, there are many scenarios, and we'll talk about some of them throughout the session. But just keeping that one in mind, there are different types of architectures that you obviously have for different types of solution. So I think the first thing to go through maybe would be like at a high level, Silvano, can you walk us through like the different components of a typical IoT solution?
Yeah, absolutely. And a common, I would say, denominator across pretty much all the IoT solutions that we've been working on are these few components, right? So of course we have our devices, our sensors and edge devices that are spread across kind of the field and are connected in a way or another with the internet, right? And the next component that those sensors will communicate with typically is called a cloud gateway, right? The cloud gateway is managing these devices, is basically collecting all the messages that are coming in and that are going to these devices. And typically, Cloud Gateway is also queuing up all these devices, because at the end of the day, his job is to make sure that no messages, no events will get lost, right? And so it typically implements some sort of queuing behind the scenes of these messages. And then that queue needs to be consumed, it needs to be processed by typically a couple of different options here. One is if I really need to intercept those events as soon as possible, I want basically the ability to process this incoming stream of messages as it was a continuous one, right? So this is typically referred to like a hot path or a warm path, where essentially, latency is super important, and we need to be able to minimize across this pipeline the latency of the ingested messages, and then apply all sort of additional processing or analysis that we want to operate on top of data, right? On the other hand, for those data points that are, let's say, less latency sensitive, right? We typically have a batch processing approach where we take, these incoming messages, we divide them into batches that can be bigger or smaller depending on a number of factors. Sometimes we refer as micro batching when we want to reduce again the latency but still ingest a lot of data as one single operation. And then behind the scenes we have different type of data stores, right? And the reason why we want to have multiple data stores is because depending on our needs, we want to find the best kind of price-performance ratio for the different type of data points that we want to store, right? So we may want to keep kind of the raw data points that we just keep there for historical analysis in historical reasons into the coldest type of storage possible, because that's the cheapest one and is typically provided in high volume, right? So this is where we can spend the few kind of dollars per terabytes per month type of price tag attached, right? And then on top of that cold storage, we can have analytical engines like Spark or other type of analytical engines that are just applying this kind of brute force approach, scanning a lot of data because they are distributed engine in nature, and extracting some intelligence from this kind of cold storage layer that we are talking about. On the other hand, where we have this kind of hot path or warm path type of processing, we need a different type of storage. Typically, we want a storage that can still ingest a lot of data points, but operate on a much faster pace on top of the data, right? Because again, latency is important. So if we want to kind of keep this kind of intermediate storage up and running, we will need to balance again the volume of data that we are ingesting with the price that we are kind of willing to pay for running this type of kind of near real-time analysis, right? Typically here is where we are looking at kind of second or sub-second level type of data points, right? Where again, it's important that we can, take the data points that we captured, put it on a dashboard, on a report, where again, potentially every millisecond counts in terms of kind of data operations, right? So those are typically the minimum kind of common denominator components that we see in pretty much all the IoT solutions. There may be more, but these are pretty much what all the solutions have. And luckily, on top of our Azure platform, we have specific services that are basically covering those different roles, right? So again, we have IoT Hub, which is the cloud gateway, is playing the cloud gateway role here, where devices can connect directly to IoT Hub, or can be connected to sort of field gateways like the IoT Edge devices, right? That are collectors or concentrators of other devices that may not have direct connectivity with the public cloud, for example. So IoT Hub is playing this kind of connectivity layer with our services, but is also incorporating that queuing layer that I was referring to. In particular, IoT Hub now is compatible with Event Hub, which is another service, is an event store that Azure has, playing exactly this role of a queue of fast incoming events that the system needs to process. And then we have for the two kind of path that we're referring to. So the hot path, we have Stream Analytics, Azure Stream Analytics, where we can basically take out those messages from the IoT Hub queue and process them as fast as possible. And then, for example, using them to feed reporting tools or dashboarding tools. And on the other hand, we have Azure Functions. Azure Functions can help to bind to this queue of events coming from the sensors and basically execute this kind of micro batching approach that I was referring to. Right? So taking potentially hundreds or even thousands of incoming messages and basically operate some transformations and put them into our warm path store, in this case Azure SQL, as we were referring to. Right, so all the other post-processing technologies, again, can be things like Azure Machine Learning or Spark with Azure Synapse or Azure Databricks can then operate on top of our warm path store or our cold path store to run whatever kind of analytical processing we may need. So that's how those basic components are mapping within the Azure services.
Awesome. Yeah, I think this is like a great explanation, and even for folks like that might be newer to IoT, it's great to see like in an agnostic way, what different components make up an IoT solution, and then how you can go through like the IoT stack and pick a solution. Now, I think for the rest of this, we're really going to dive into how Azure SQL Database plays into this. So I thought maybe the next thing that we could do, Silvano, is you could walk us through some considerations when it comes to why Azure SQL Database and how Azure SQL Database can kind of achieve this IoT level of scale.
Absolutely. With Azure SQL Database, again, we have a lot of options within the Azure platform in terms of data stores, right? We have relational data stores, we have NoSQL data stores, and then we have all sort of kind of blob storage type of kind of cold storage, as we were referring to, right? So Azure SQL Database plays well this kind of hot and warm type of storage role, because first of all, it is scalable. It can scale if you move with the bullet points. Right now we can scale up to under 28 vCores with a single instance, right? A single database, and up to 100 terabytes for the hyperscale tiers, right? This means the ability to ingest a lot of incoming messages, billions and billions of incoming messages with one of the lowest latency possible, right? This means that we can leverage some of the intrinsic capabilities of Azure SQL, like the ability to bulk insert thousands of events as a single operation, which will make this kind of warm or hot store very competitive from a performance perspective, also with other NoSQL stores that may have the same capability, but they typically don't have the ability that Azure SQL has in terms of fast querying, fast analytical query on top of this ingested data, right? So the batching on one hand, and the ability to, on top of the same data that we have ingested, to create optimized structures like clustered column store indexes or in-memory optimized tables that can be used in order to scale even further, the usage of Azure SQL Database in our IoT solutions. The interesting thing is also that IoT data points are typically JSON based. And so these data points are coming into this semi-structured or non-structured fragments. And with Azure SQL, we can actually process JSON data points. We can store JSON as is in our Azure SQL tables, or we can basically take the JSON attributes and values and shred it into relational table, depending on our needs, right? So the typically transforming into relational data points is the best solution in terms of performance and in terms of reducing the volume of the data points that we store. But we know that customers, in some cases, they want to store the original message that these IoT devices have sent, right? So again, with the ability to scale up to hundreds of terabytes, like the hyperscale tier can do, we can actually combine the best of these two aspects, right? The low latency ingestion part and the ability to store, high volume of data points and to be able to immediately query. So we don't need to move data to another analytical engine in order to be able to run aggregations or complex analytical queries on top of that. This is an important aspect.
So what you're saying there, just to make it clear to our audience, is like, instead of previously how we kind of had a cold path and a warm path, it's possible to use something like Azure SQL Database for both of those paths.
You're breaking up a little bit, Anna, but I think I understand your point. Yeah, that's exactly true. So the Azure SQL is providing this great combination that sits between, let's say, the cold storage characteristics that I was referring to, the ability to have large volumes and even a relatively cheap price, and at the same time to be able to ingest these low latency data points that are coming in, right? So it may not fit all the different kind of requirements and solutions that other specific scenarios may have, but in this case, it fits perfectly fine for that warm path store that I was referring to.
Gotcha. Awesome. Makes sense. So after all this, and after Silvano's worked with many customers and our team has worked with many customers, Silvano and team have kind of created this recipe for IoT solutions using Azure SQL Database. So what this also represents, what you're seeing on the screen now, is kind of the solution that we've built in Microsoft Learn that you can get hands-on with. So you can see what we're using for kind of device simulation is we're going to be using an Azure virtual machine and then containers to simulate, in our case, about 1,000 devices. And Silvano will show later how you can actually use this solution to scale to much more than just 1,000 devices. We'll also be using Azure IoT Hub to kind of help with that, kind of almost like Event Hub would help there, as well as Azure Functions, bringing that data into Azure SQL Database. Hyperscale, we'll be able to take a look at that using something like the query editor or SSMS, but we'll also be able to look at it with Power BI. So with all that being said, I thought it would be a great opportunity to kind of take a look at the exercise and take a look at how you can get hands-on with this in Microsoft Learn. So let's go ahead and take a look. So I'm going to go back into the module, and what you're going to see is that there are different text files. So if you want to go deep into the various topics that Silvano and I are discussing, you can read more about them. There's references to other materials to dive deeper as well. But then there's also some exercises. So what I've done is I've opened the first exercise, and you can see a few things here. For those of you that haven't used the Microsoft Sandbox before, just wanted to call out that this sandbox is available for 2 hours. So you can see I've already had mine spinning up for a while, but you can have 20 sandboxes a day. And once you have a sandbox, you can basically log in with your account. You can keep track of kind of your progress in various Learn modules, but more importantly, you can deploy resources for free in kind of the Microsoft Learn type of subscription. So this is going to take you step by step. We'll talk about what's going on the right in just a moment, but the first thing you're going to do is you're going to use an Azure Resource Manager template, or what we call an ARM template, to basically deploy all the pieces of this solution. And in this example, you're essentially going to supply some unique IDs for the various pieces of this template. And then we're going to clone the repository. So you will have access to this repository. It's just on GitHub. So again, that goes with what we'll talk about later where it comes to customizing and using your own. But you're essentially going to deploy the template, and it's going to deploy a bunch of different things so that you can set up this architecture and also connect it all together and then be able to monitor it as well. So once that happens, and again, this script takes about 5 to 10 minutes to complete, so I did go ahead and do it in advance. But once this happens, you can hop over to the Azure portal. And again, for those of you who haven't seen this sandbox before, you can see up here, I'm connected to the Microsoft Learn sandbox. So I'm not connected to like my corporate subscription or tenant. So this is going to mean I'm going to have the permissions to do what I need to do. And you can also see that this template has gone ahead and deployed things for me, like an Azure SQL Database, which we'll take a look at, an IoT Hub, let's see, a virtual machine that we'll use for our simulator, and Azure Functions. So all these different components that we're going to need are going to be deployed by this template itself. Now, once you deploy the template, the next thing you're going to want to do is set up your Azure SQL database, okay, right? So we're going to suggest kind of like a base schema for you to use. And again, we've made this really easy from a deploying and getting started perspective, whereas we're just having you kind of apply this script to the database to set up your database. Now, again, you can go look at this script. It's hosted in the GitHub repository, and you can see what's being created. You can add or adjust as needed. You can change the names of stuff, but this is just going to help you get up and running really quickly. Now, once you've done that, the next thing you're going to want to do is start to connect the connection strings of these things together. So what you can do is you can go into essentially the Azure portal. You're going to gather connection strings from IoT Hub, from the Azure storage account, and you're going to connect those things to the Azure function application. So what you're going to see here, that's the function loading. But if we take a look at the configuration here, now the template does most of this. You just need to come in and specify your specific connection strings, but it's going to allow you to specify connection to that IoT Hub, connection to your Azure storage account, and a connection to Azure SQL Database Hyperscale. And then you'll be able to kind of see this function running in action. And we see we have this IoT workload function, and you can go into monitor. So the log analytics is already set up for you, so you can kind of monitor the success of this, and you can even get some real-time logs and see, let's see, it moves a bit fast, but you can see it's taking in those messages and it's processing them, and then it's able to kind of batch them and send them to Azure SQL Database. So that's kind of at a high level, some of the things that are deployed. I'm going to skip past some of this because we already did this, but the next thing you'll want to do is actually start the simulator. Now, this simulation is very cool. Essentially, what we've done on the right-hand side is we've connected to a Linux virtual machine, and then we're using Docker. So we go through the process of installing Docker, and we're essentially able to pull down the Azure IoT device provisioning container. So again, this is just the simulation side. This is a piece where you would want to customize on your own, but we're able to go in and pull that down. And then here in the next thing we're going to do is we're actually going to run a bunch of containers. So you can see we're giving the IoT hub connection string, and we're specifying some things about the simulation. Again, there's more documentation on how to specify this, but we're basically saying, hey, we want something between 80 and 90s, a random value, and we can just set this up. We're saying it's an engine and we want to provide on-off value. So for our truck simulation fleet, this is going to work for us because we can say we're monitoring the engine temperature and whether or not the engine is on or off. Now down here, what you can see is we're able to see the device count. So here's where I was mentioning earlier, we're doing about 1,000 devices. We can also specify the interval of messages and the container we want to use. But all this being said, that's what you're seeing on the right-hand side. We're bringing in a ton of different messages. And then finally, as part of this exercise, we already looked at the Azure Function app, but you can also use the Azure portal. And the reason I use the Azure portal is just if you want to do all of these exercises from a browser, that's possible. Of course, going towards production, you probably want to start using other tools like SSMS, Azure Data Studio. We'll take a look at some of those in just a bit. But I think at a high level, this shows you, and sometimes it's kind of hard to see all these things here, but this shows you an example of what's being brought in. So we're able to see for each of the devices, we're seeing a timestamp. We are bringing in that raw JSON data, but we're also able to, as you can see, take out things like the device ID, the temperature, which you see over here. So we can keep JSON in its kind of normal format, or we can bring it into that table format like Silvano was talking about earlier. So that's kind of just like a quick look at what the first exercise does. And I hope you'll try it out and get hands-on with this. It's a great learning experience, and it's also cool to see what this solution actually does. So if you go through that exercise, what you're going to be able to see is the ability to kind of set up your environment and deploy the template and get everything kind of running for this simulation perspective. And we do have a few questions that have come in. Also, we're seeing things like there are trillions of IoT devices, seeing some thumbs up, seeing some things. People think this is cool. So I'm glad to hear that this is resonating with some of our viewers. Maybe Silvano, there are a few questions here. I'm not sure if you want to take either of these.
I think some of these have interesting are raising interesting questions actually. So trillions of IoT devices. I think IoT Hub itself has some limits in terms of how many devices it can connect. Potentially, it can go to the millions of devices for sure, and they can generate trillions of data points. That we have actually one of the customers I was referring to. He has an IoT solution collecting from different devices in the field. We are talking about hundreds of thousands of devices, and they have in a live production environment several trillions events stored in an Azure SQL hyperscale database, and they are running predictive maintenance on top of those devices are wind turbines that are spread around the world, and they are observing the efficiency of how the different components of a wind turbine are working, and they are running predictive maintenance algorithms on top of that, and in their live system they have several trillions of data points, right? So it is totally possible to scale to that level. And to answer the other question around geo-referenced data stores, yeah, I mean, the Azure SQL actually does support the geospatial data types and the ability to query geospatial data types with specific indexes, right? So if we take that JSON, incoming JSON, even in our demo here in the MS Learn module, and we just change the construction of the simulated JSON fragment, and we add some geospatial data types with that, you can actually test it, right, and leverage the geospatial functions that Azure SQL is bringing out of the box to create your, for example, ring-fenced query and see, for example, if a device is moving out of a certain kind of perimeter and so on. So that is an interesting exercise that you can kind of play yourself in the demo environment here.
Cool. Awesome. Awesome. That's pretty cool. I actually didn't know that, so I'll have to go check that out. So moving right along, like now we've kind of seen like how to get this thing up and running. Hopefully you all are feeling kind of excited about the possibilities here and the different things you can test out. I even just learned you could test out kind of the geospatial capabilities with this device simulator that we've shown you how to set up. But I thought maybe we could take a step back, Silvano, and you could tell us a little bit more about different patterns for ingesting a ton of data. I know I've heard a ton about this shock absorber pattern, so maybe that's a good place to start.
Absolutely. I mean, in the module, we deliberately kept the schema and architecture of our solution simple, so that kind of people can start learning about that and then can start applying some additional optimization, right? One of these optimization is, for example, the introduction of what we call memory optimized tables, or LTP memory optimized table in the design of our solution, right? This means that we can increase the amount of data points that we can ingest from the sensors and increase the concurrency of ingesting multiple data flows in parallel by leveraging this in-memory technology, which is available in Azure SQL Database business critical and premium service tiers. And with this introduction in our architecture, we can use this in-memory table, which, I mean, because it's in memory, is not infinite from a data volume perspective, right? So we can keep it relatively small, like a few hundreds of gigabytes, for example, in the database, and then offload the incoming messages, the old messages that are sitting in the in-memory table into a column store based table where data will get compressed and will get organized from an analytical perspective in this kind of columnar format, right? Where this format is highly optimized for those aggregations and that kind of analytical queries, right? So taking the existing schema and adopting the shock absorber pattern means basically adding this in-memory front-end kind of table that is, again, accepting the ingested data points at the beginning, and then having a recurring kind of threads that behind the scenes is kicking in and is taking those older data points that we don't want to keep in memory anymore, because maybe we have this requirement of fast ingestion, but for kind of few minutes or few hours for our kind of data streams, incoming data streams. And then after those few hours, we move the data to the column store based table, and we will live there for potentially months or even years, right? Depending on what is the maximum amount of data that you want to the maximum amount of time that you want to retain your data points. So this is a well-known technique. With a single Azure SQL Database instance adopting this pattern, we've been able, and there's an article in the in the module, there's a link to this article where we are proving to be able to ingest more than 4 million events per second. So it's a very interesting kind of benchmark that is proving that effectively with a single instance of Azure SQL, we can scale where other data stores actually require to have a clustered architecture with potentially tens of nodes that are really powerful, but even very, very expensive. Right, so this is why we think that Azure SQL plays a great role in these IoT solutions.
Awesome, yeah, and I think like this is a great dive, and I love just I think a lot of our SQL Server people are very familiar with column store indexing in SQL, but for those that might be newer to Azure SQL Database, can you tell us a little bit more about how that works?
Yeah, absolutely. So relational data are typically organized in kind of rows and columns, right? In the past, the way those rows and columns were stored on disk were with a kind of particular data structure that again was organized by row. Right, so every row was a new entry in that data structure, and then all different B-tree indexes were built on top of that to facilitate, to kind of speed up kind of data retrieval, right? But when we have to do this kind of analytical queries, and where effectively the goal for these analytical queries is to scan for some values, for some columns, a large amount of data points. This row-based way of storing data on disk can be very expensive from an I/O perspective specifically, right? So column store index is coming in and is basically organizing data on disk with a different approach, right? And is basically organizing the incoming data that we are storing into the table in this columnar-based segments, right? So basically, first of all, we are splitting into row groups, so large batches of groups, typically up to 1 million rows in one of these row groups, and then we are basically storing on disk the column values, right, into these columnar segments, and we apply compression because it happens that in a lot of this kind of data warehousing or analytical solutions, a lot of values within those rows are actually repeated, right? So by applying compression, we can reduce significantly the space that we have on disk, on our kind of disk-based tables. But at the same time, we can also speed up queries where the pattern of the query is, for example, to group a certain number of rows and to apply some analytical or some aggregation functions on top of values for all those rows, right? Column store indexes can still accept the new rows to be inserted. That's why we have this additional data structure called delta store, where we store kind of new rows that are inserted into our column store base table until the amount of rows in this data stores becomes big enough that we can run, an additional thread of that compression algorithm, and we can basically compress those rows into a new row group and into a new bunch of column segments over there, right? So this is the way column store indexes can actually be modified. So new rows can be written, rows can be deleted, and can be updated like, for example, traditional row-based column, right? So this is a very, very important asset that we have in Azure SQL to speed up analytical queries.
Awesome, cool. That explanation really helped, so thank you. The next thing I kind of wanted to ask you a little bit more about was around optimizing storage and retrieval with JSON. And when you think about this answer, one thing I wanted to throw in there is we did have a question from Learn TV if there was any particular reason for not using Cosmos DB, and the reason they give is since that handles JSON better. So maybe a few questions, but how JSON plays into all this.
Yeah, I mean, the idea here is to find basically and to use the right store for the right purpose, right? So if I have to ingest a lot of data points in the fastest way possible, from potentially millions of devices. Some NoSQL data stores like Cosmos DB, they do a great job by scaling out basically their resources and to basically apply some sort of brute force approach to the ingestion part. But where those engines are a little bit more complex in order to get better performance is how to run those analytical type of queries on top of that. So if my goal is just to ingest the data, and then at some point I will have a kind of a Spark engine or a similar type of kind of big data engine that is just running aggregations again with a scale out approach and calculating some results. Cosmos DB and other databases like that are effectively doing a great job. But where Azure SQL makes the difference is in offering the best of both worlds, right? So this analytical portion in engines like Cosmos DB is much more complex to achieve. You have to redesign completely your data models. You have to think about how basically to reduce the number of these RUs, these request units, in order to get better performance on scanning a lot of individual messages in a NoSQL database. While on storage systems like Azure SQL, you have it out of the box, right? So you have the ability here to manipulate JSON data types, as I was saying. So we have a bunch of built-in functions from kind of OpenJSON in order to be able, for example, to transform a JSON fragment to a table, or we have built-in functions to extract values from a JSON fragment and do something else, right? What is the best approach? It depends. It depends on what do you need to effectively do, right? If you need to retrieve those original JSON fragments to store it in their original sense, you can actually use Azure SQL and store the original data messages in JSON over there, and then you can post-process by leveraging those JSON functions. If instead you don't care about the original kind of structure of the message, one good option here is to take the incoming JSON fragment, to leverage those built-in functions, and to transform those data points contained in the JSON fragment into columns in your kind of relational structure, right? So this is giving you the best of both worlds. In fact, as I was saying, in a single Azure SQL instance, you can go to millions of JSON fragment inserted per second, if you like, right? This is a result that even with Cosmos DB or other NoSQL engines is definitely not trivial to achieve. But at the same time, here you can start querying in the immediate second, actually within a millisecond, within a less than a second in terms of data latency. I will show you later on a quick example of what I mean. Basically querying several billion JSON fragments in less than 1 second on a kind of analytical type of query. This is definitely not possible with one of those engines. Then you have to have something on top of, like Cosmos DB, for example, has Spark that can be used in order to achieve that that kind of analytical kind of query approach. But Spark comes with a lot more latency because a single response with a Spark query needs to be elaborated across a bunch of distributed nodes, and typically you cannot get that less than 1 second from ingestion to query time that I was referring to.
Awesome. Yeah, I think that helps. And I think in general, it's a really interesting discussion of kind of it depends on what you wanted to do. One thing I wanted to talk about before we get into the next demo and then like how you kind of can scale out this solution is how you can leverage replicas. So I'm just going to animate through these. But what I wanted to mention is there are various ways that in Azure SQL Database, you can get read replicas, which you can use for reporting, you can use for analytics, you can use if you're doing kind of these HTAP type of workloads. So just to go through them quickly, in Azure SQL Database, you can very easily deploy geo replicas in the same region or different regions, depending on which service tier you're deploying. You can also deploy auto failover groups and leverage kind of the secondary there for read-only applications. Same with the business critical service tier, gives you one read-only replica that you can leverage for these read-only type of workloads. And then the final thing that I think is just really powerful is if you really need that read scale, like hyperscale is definitely going to be able to give that to you. If you look at hyperscale today, they have geo-replication in preview, which is going to allow you to get one replica of your database. Additionally, you have the option to deploy 0 to 4 high availability replicas. So these are used primarily for high availability, but you can use them to kind of scale out your read workloads as well. And then what's really interesting, and this is kind of new, is these idea of named replicas, where you can essentially have a replica with a different name, different authentication. It can have a different compute size. So maybe you're, for your ingestion workloads, you only need like 2 or 4 or 8 vCores, but for some of this heavy analytics you're doing, you sometimes need, more like 40 cores or something like that. These are great because you can kind of scale them up and down on the fly. You can deploy them. It's not a size of data operation to kind of deploy these. So there are lots of great solutions when it comes to getting access to read-only workloads while not wanting to interfere with the ingestion activities that you're doing. So I just wanted to call that out. The other thing before we kind of get into just the demos and wrap-ups and everything is, like, I know, Silvano, there are other things that folks should consider when it comes to building these IoT solutions with Azure SQL Database. I know there's probably a lot you could talk about here. Like, what are the kind of the highlights that you would want people to know?
Yeah, absolutely, and those are actually small things that you can start applying even in our demo environment here. For example, at some point we may want to apply some sort of kind of sliding window pattern, right? So, for example, we may want to keep the last, let's say, 12 months of IoT data points within our Azure SQL and move, for example, the old data points somewhere else, right? So if we create a properly partitioned data table, for example, using a kind of a time-based partition on a monthly base type of interval, we can leverage Azure SQL intrinsic table partitioning mechanisms in order, for example, to prune an entire old partition of data and create a brand new one to start accepting the new incoming events, right? So this is great because basically is giving us this kind of infinite scale, if you will, where you can go ahead with the same instance and never forget about I'm filling up my instance over the 100 terabytes limit that we have in Azure SQL Hyperscale today, right? So you can, and also it's a great approach to keep kind of costs controlled, right? Because at that point, you know that you only want to keep, let's say, the last 12 months of data points, and this will be an X amount of gigabytes, and you will use the precious Azure SQL kind of data volume, data store for these type of warm path data analysis, and then you can use, for example, blob storage to keep high retention data and execute kind of queries with other analytical engines. Now, I noticed that there was an interesting question from Fulsnabel. If we have this kind of big query-like type of solutions in Azure, yes, we actually have Azure Synapse, which is exactly offering that kind of scale-out architecture, and will give us the ability, for example, to take Azure blob storage account containing IoT data points, and without even kind of importing the data or transforming, to leverage the SQL on-demand type of data pools within Azure Synapse and start querying those Azure storage account as cold storage in our IoT solution, implementing exactly that kind of pattern, right? So use the right store for the right purpose. Azure SQL is great in this kind of warm store type of scenarios because you can ingest a lot of data and start querying the data almost immediately with great kind of analytical performance. If you don't need to store everything in there, you can leverage a kind of cheaper type of storage types like Azure Blob Storage and leverage some of the other kind of big data type of processing engines to do the historical type of analysis on that.
Awesome. Thanks, Silvano. Just for time, let's go into the second demo, and then I wanted to kind of pass to you to show us how we can scale and how you've kind of scaled this out in your solution. So if I hop over here, what you're going to see is there is one more exercise, and this exercise is just going to take you through some of the configurations and tips that Silvano was mentioning around data compression and partitioning. I'm going to skip that for now. What you'll see at the very end, and this is almost like a bonus thing, is this ability to download a Power BI file, which I wanted to show you. So this is a Power BI dashboard that I created, and I haven't refreshed it in a few seconds, but a few things you can see is just from the hour or two we've been, I guess hour and a half we've had this running, we've got over 37 million events in the data store. You can see our average latency is very, very low, and we can even get a look at some of the different time series buckets views. So if you wanted to group things into certain windows, like Silvano had mentioned earlier, and you can see all of the raw data points coming in here, and we can even play with making some graphs or looking at specific devices. So all that being said, this was very fast, but please go try this out. Silvano, I'd love to see like how this scales. So just to put in perspective, this sample that you could deploy has 1,000 devices, and you can see how much data we're kind of bringing in as we go. But what are the kind of the possibilities from this?
Yeah, absolutely. So I have here a similar environment that I deploy in my own subscription, starting from the same exact sample that we published in the learn module, and you can see here my database right now is something like 38 terabytes of ingested data points. I'm using right now something like 13,000 devices, and I'm generating a new event for all those devices like every half a second, right? So we can see, these are around 1 billion new events per day, if you will, right? So I can show you right now the data structures that I have, and this first column here is the row count. You can see those are is a very big number, but are more than 70 billion records in this events table that we have here, right? And what I was referring to previously in terms of kind of low latency in ingesting to read type of process, I can show you. I'm basically querying this table here, reading the last event that I'm just ingesting in this system. This is the timestamp of the event that has been inserted into the database, right? So is the 59 second dot 360 milliseconds, and you see the event was originated at the 58 seconds 29 something, right? So this means that essentially we can query this typically on a less than a second basis, right? So the difference between these two times here is giving us how fast basically the system is from when the event is generated in the device, in the field, in this case, in the simulation VM that we created, from when the data are basically stored in our database. And we can query the data. And just to give you another example here in terms of performance, we are right now ingesting those 15 to 20,000 messages per second in this database. This is not a big database; it's an 8-week core data instance that we have here, and I can query these data points with a typical time series pattern where I'm taking 4 devices here. Let's change it just for the sake of demonstrating that this is live. So I'm taking device number 1, 2, 4, and 12, and I want to compare their data points ordered by the time when those were generated and see how they were behaving, right? And if I execute this query, I can see that it's basically executing in less than 1 second, as in giving me back these around 300 rows that are basically the aggregated value for the temperature of our engines on a 10 minutes by 10 minutes basis, right? So we are bucketizing, grouping all the reads in these 10 minutes buckets, which is again a typical time series type of pattern here. And then we are calculating the average temperature of the engine for each device in that list, right? So you can see the question again, can we use other engines here? Yes, of course, Cosmos DB and others, but you can rarely get the same level of performance when you are aggregating data points across a bunch of data streams that are coming in, and with using literally a fraction of the performance that we have in that database. As you can see, these are the amount of CPU that we are using. By the way, ingesting around 20,000 rows per second. I also wanted to show you another interesting exercise here. On top of the same solution that you can deploy in the module, in the Learn module, you can also create your own monitoring systems, right? This is a dashboard that I created on top of that same solution, and I'm showing a bunch of data points coming from different metrics, right? For example, this is coming from my IoT hub, and it's giving me the amount of messages that I'm consuming on a daily basis, right? So if I click here and I show you, for example, the last 24 hours of data points, you can see that I'm around 1 million messages, between 800 millions and 1 billion messages per day, right? That our system here is ingesting. And I've been using the Azure Monitor metrics together with some other analytical data points here that are coming from App Insights and so on to monitor things like, hey, how many rows per second is ingesting on any given moment in time my database? What is the average latency for each rows that is ingested? Around 3 milliseconds, as you can see here. How many rows I'm inserting on a single batch, and then I have multiple batch executing, and then I have the amount of data that is currently allocated in that database, and as you can see is around 36 plus terabytes. And of course you can monitor other metrics like, for example, your CPU, data IO, and log IO in your Azure SQL database together with the other components of your solution. So one exercise that you could build on top of the MS Learn module is to create your own customized dashboards to see the kind of the end-to-end performance of your IoT solution deployed.
Awesome. Yeah, I think that's really cool. And I think just to show, like you'll get some of that in the Power BI dashboard, but if you really want to go deeper, then I would definitely recommend, going and checking out how to kind of build these custom dashboards. And I believe it's relatively straightforward to set these things up and pin to a dashboard. But with that being said, we are just about at time. So what I wanted to do is just wrap by reminding you all that we have this new wonderful Learn module that we hope you'll check out at the link at the top of this page. If you go into the module, you're going to learn more about these various strategies and patterns and techniques you can use to get the most performance and scale out of your Azure SQL database for IoT samples. You can also get hands-on for free, and then maybe even challenge yourself to kind of go and try building some of these Azure Monitor dashboards with the template provided. Hopefully you've seen how you can modify this template to meet your IoT scenario needs. And we also have the code sample code if you want to go straight to the GitHub. That's that GitHub URL that has the Power BI file, the SQL schema queries, the other SQL queries that are run, the ARM template. Everything you need is in the Azure, the GitHub repository. And then finally, if you want to come back and check out this video later, see some of the cool stuff, or hear someone re-explain some of the topics we talked about today, then you can subscribe to our YouTube channel, and that's where this video will be posted. As we close out, Silvano, I just want to thank you so much for coming on the show. Do you have any final words of advice for folks that are kind of just getting into this space?
Yeah, I think my last word is definitely kind of play with it, play with this module that we created. I think it is going to be a lot of fun for you, and then start tweaking areas like, for example, how long I want to retain the data points by leveraging this data partitioning strategy that I was referring to. How I want to store maybe more additional data points by customizing the simulator template and start increasing the level of features that you want to manage as part of your experiment. So, and let us know how and if you like it, and if you have some specific requests, please kind of feel free to reach out to us, and we will monitor all the different channels to make sure that we will respond to your questions.
Definitely. Awesome. Thanks so much, Silvano. Thank you to our viewers who are joining us. If you like this video, go ahead, give it a like, comment, and let us know what you're doing with IoT and Azure SQL Database. And we hope to see you next time on Data Exposed.